So in this problem, which is 6.5.23, we're talking about money and our interest, or money getting deposited into an account, etc., etc. Okay, and as you read through it, you should recognize it as the future value of an income stream, that's what they're asking you to find. So let's review that. So if you have a bank account with money coming in continuously throughout the year, your interest is compounding continuously, you can find the total amount you'll have in the account after a few years, and that's called the future value. K is the amount of money deposited each year, N is the number of years, and R is our interest rate. Okay, and then here's our future value equation. So let's look at this problem again. So suppose the money is deposited daily into a savings account at an annual rate of $13,000. Okay, so this is telling you how much per year. That's your annual rate. So K equals 13,000. If the money pays 8% compounded continuously, so that's your interest rate, is 8% or 0.08, estimate the balance in the account at the end of 2 years. So our number of years is 2. So let's go ahead and put it in. This is just a screenshot so you can see the answer there. We can double check ourselves. So our future value after 2 years is going to be equal to the integral from 0 to n, 0 to 2, of k, or 13,000, e to the r, which is 0.08, times n, which is 2, minus t, dt. Now you might look at this integral and think, I don't know how to find the integral with this in here. And technically, you don't. Our textbook kind of fudges, and as the people wrote in the answers, they kind of wrote in the answers using what they know from an upcoming chapter that you don't know yet. However, with some clever rewriting, you can make this something that you do know how to do. Okay? Because this can be the same as, let's multiply it out, so 0.16 minus 0.08 t. And if you think about it that way, what do we do when we have e raised to the power? If we have an addition in our exponents, we can really write that as a multiplication. Or like this is e to the 0.16 times e to the negative 0.08 t. And you do know how to take the integral of that piece. So with that in mind, let's rewrite this. So we have the integral from 0 to 2 of 13,000, okay, times e to the 0.16 times e to the negative 0.08 t dt. Now this entire thing, even though it's e to a number is still just a number. That's still just a constant. And so really, you can ignore those, or you can even pull them completely out of your equation, out of your integral. So we'd have 13,000 e to the 0.16 times the integral from 0 to 2 of e to the negative 0.08 t dt. So we rewrote a lot of things, used our knowledge of exponentials, but we're now down to something that you do know how to take the integral of. So to do that, we still have our 13,000 e to the 0.16, because when you just have your constants here, you don't do anything to them. And then when you take the integral of e, you keep it the same, but we're going to divide by whatever's in front of the t up there. So we're going to divide by negative 0.08. And we'll evaluate this from t equals 0 to 2. At this point, I'm just going to put it in my calculator because we've done quite a few of these. And I get 28,195.516. And as you can see in their solution, they did round up.